Welcome to this explainer. I am so thrilled to guide you through today's topic. We're looking at a truly fascinating piece of modern tech, Supermicro's SuperCloud Composer, and we're zeroing in specifically on the cooling infrastructure module. Now, if you manage a data center, you already know the stakes we're dealing with today, right? The sheer volume of heat generated by modern, high-density server racks is honestly staggering. Managing that heat effectively isn't just about keeping the lights on. It's absolutely crucial for extending the life of your hardware and optimizing your entire facility. So that brings us to the million-dollar question. How exactly do you cool high-performance servers without totally breaking the bank? With processing power just constantly skyrocketing, traditional air cooling, well, it just isn't cutting it anymore. The heat produced by this high-octane processing is basically an existential threat to data center efficiency. So the ultimate solution is liquid cooling. But to make liquid cooling work at scale, you need a seriously powerful, centralized mission control to monitor and manage the whole shebang. So here is our flight plan for today. First, we'll talk about taming data center heat. Then we'll go inside the SCC dashboard, monitor some in-rack CDUs, and finally look at managing CDU firmware. Let's jump right in. All right, Section 1, Taming Data Center Heat and the Liquid Cooling Evolution. Look, if you're running high-level processing today, advanced thermal cooling is absolutely no longer optional. The core piece of hardware doing the heavy lifting here is the in-rack CDU, or coolant distribution unit. Think of this as the beating heart of your liquid cooling setup. By keeping a close eye on these units through the SuperCloud Composer console, administrators can maintain peak operating efficiency in their high-power racks. And here's the real kicker. Managing these CDUs effectively directly improves your data center's power usage efficiency, your PUE, and it significantly lowers your total cost of ownership. Moving right along to Section 2, inside the SCC dashboard, which is essentially your mission control. When you open it up, consider this interface your personal toolkit. You've got a massive scale of tools right at your disposal within the cooling infrastructure menu. You can manage everything: in-rack CDUs, in-row CDUs, sidecars, rear door heat exchangers, and even your overall cooling towers. It's this incredibly comprehensive suite designed to put literally every single cooling asset right at your fingertips. And getting around this user interface is highly intuitive, mostly because it relies on standard, recognizable action icons. For example, you're going to frequently use the little eye icon to instantly display resources or physical assets, and you'll use the magnifying glass icon to filter and search through massive datasets. Once you master these simple icons, you can just glide through the UI effortlessly. Now, when you open the in-rack CDU module, you're greeted with this list view. This is your high-level telemetry overview. In one quick glance, you get an immediate pulse check on your entire fleet. You can see the physical location of the unit, its IP address, the group name, the status of the control unit, and the overall CDU health. If something goes wrong, this is exactly where you're going to spot it first. Which brings us to Section 3, monitoring in-rack CDUs, or basically reading the vital signs. We're shifting gear from just looking at the fleet to really inspecting the real-time sensor data. Here's a quick breakdown of the critical environmental metrics the system monitors. It's honestly like monitoring the vitals of a high-performance race car engine. The SCC application is constantly pulling data on the CDU health status, the physical pump and valve status, internal pressure and flow rate, temperature, total heat load, and, critically, the humidity and dew point inside the rack. Every single one of these data points is absolutely essential for avoiding a hardware failure. Now, you might be wondering, how does the software actually get all this info? Well, for the high-capacity units, like your 100 kilowatt or your EIA and OCP 250 kilowatt in-rack CDUs, SCC retrieves this sensor reading data in real time using the Redfish API. It strictly follows Open Compute Project, or OCP sensor categories. By organizing this data meticulously into categories like pumps, leak detectors, and reservoirs, the system lets admins catch anomalies instantly. This prevents disastrous, not to mention expensive, hardware failures. Okay, you'll definitely want to keep this quick reference guide for CDU status codes in mind. When you're looking at the dashboard, good naturally means normal operation. Warning means at least one sensor has hit a warning threshold. But alert requires your immediate attention. That could mean a control unit failure, a specific device failure, or a critical sensor alert. You might also spot a memory error if the unit's non-volatile memory is full. But the one we really need to focus on is condensation risk. Let's actually zoom in on that one right now. A condensation risk status pops up specifically when the facility's water temperature drops below the ambient dew point temperature. And why does this matter? Well, water and high-voltage server electronics, yeah, they do not mix. If condensation forms inside a server rack, it poses a literal life-or-death, catastrophic threat to the hardware. That's exactly why having a dedicated dew point sensor feeding real-time data back to your SCC dashboard is so vital. Now, if you're managing hundreds of racks, finding that one specific alert probably sounds a bit daunting, right? Thankfully, SEC lets administrators hunt down specific alerts using multiple search filters. You just click the magnifying glass icon, enter your criteria, maybe an IP address, an alert status, or a serial number, and hit enter. The system smartly applies an "and" condition across all the filters you fill out, narrowing down your massive dataset to the exact unit that needs fixing. All right, final stretch. Section 4, managing CDU firmware, or as I like to call it, maintaining the fleet. This is the operational phase where you ensure your cooling fleet is running the absolute most up-to-date software. The data here is presented in a highly intuitive hierarchical tree view. This lets you easily and logically navigate to the exact location of a CDU. You can literally drill down from the overarching pod, right into a specific group, down to the exact rack, and finally the drawer to manage that specific unit's firmware repository. It's super smooth. And updating that firmware is a straightforward but obviously highly controlled process. Step 1, you navigate to the in-rack CDU firmware list in the data browser. Step 2, you just click the plus icon, which takes you straight to the upload page. And step 3, you upload the system in-rack CDU firmware image. It's designed to be seamless, but you definitely have to pay close attention. And I mean really pay attention. When you initiate an upload, you're going to receive a very clear cannot miss it caution prompt. The stakes here are high. Firmware updates are permanent, and the existing contents will be overwritten. Plus, the system strictly requires that the CDU firmware version you are uploading is higher than version 1204. So you must be absolutely certain before you click OK. Now, over time, your firmware repository is naturally going to fill up with older versions. To manage your storage capacity efficiently, you can use the little pencil icon to edit the descriptions of your existing firmware files, or just use the trash can icon to delete outdated firmwares entirely. Keeping this repository squeaky clean ensures your team always selects the correct, most recent software for your liquid cooling fleet. As we wrap up this explainer, let's look at a fantastic quote from our source material. Improve your data center PUE and TCO with Supermicro's liquid cooling solution. Everything we just explored in the SuperCloud Composer dashboard today, from that real-time leak detection to the meticulous firmware management, is built to serve this one ultimate goal. By mastering this mission control, administrators lock in massive savings in power consumption and total operating costs. It's a real game changer. So, I'm going to leave you with this final thought to chew on for your own facility. With server processing power constantly rising and heat generation basically compounding every single year, is your data center infrastructure truly ready for the liquid cooling revolution? Mastering tools like the SuperCloud Composer might just be the deciding factor. Thank you so much for joining me for this explainer, and I hope this gives you a powerful new perspective on managing data center thermal cooling.